All right, let's go ahead and get started. A couple of things just to remind you guys that, let's see here, you just had your quiz number 2, which means what's next? Coming up in a week, quiz number 3. And we'll be focusing on this week, section 2.3, A and B, and a little bit of 2.4. So let you guys know what's coming up this particular week in terms of lessons that you guys have to do and stuff. So, all right. So, rest like we're in. Don't procrastinate. Whatever you do, don't procrastinate. How many times I got people, students who went, don't have internet service and I'm in trouble. Well, don't wait till the last minute before you're out of town before you discover that you have a homework set due. Go ahead and get it done now. All right, today we're covering the definition of derivatives and the power rule. All right, so before we get started, let's talk about what we learned last time. There are 2 formulas I want you guys to know for the derivative. Okay? So the first one is f prime of a. Okay? F prime of a, this is equal to the limit as h approaches 0 of f of a plus h minus f of a all over h. Now what this is a formula for, we talked about last time. This is a formula for the slope of the tangent line at a point x equals a of some function f of x. So we're talking about, you got this function f of x, and you got this point A you're interested in, and you want to know what the slope of the tangent line is. The slope of the tangent line is the derivative evaluated at a. Okay? Now, behind that, so when you find the derivative evaluated at a, this is going to be a numerical solution. What do I mean by a numerical solution? You can get a number. Slope of the tangent line is 2/3. You're expecting a number. Rise 2, run 3 type thing here. It's going to be a slope. It's going to be a numerical value. This is f prime of a. Now, behind that, the other formula is f prime of x. This similar formula is the limit as h approaches 0 of f of x plus h minus f of x divided by h. This is a formula for the derivative of f of x. You're expecting this thing is going to be equal to a function. Now, I'm going to talk about what this function is actually going to give you. This is a function of x and the relationship between the two. So let me give you an example. Okay? So this first example here, I'm going to give you a function. F of x is equal to x squared plus 5x minus 2. There's a nice function. F of x equals x squared plus 5x minus 2. Question A here. Find the slope of the tangent line of f of x at x equals, let's see here, 1. Once you find the slope of the tangent line of this function, x squared plus 5x minus 2 at x equals 1. So officially what we're looking for here in terms of my formulas is this slope of the tangent line of f of x at x equals 1 is really f prime of 1. That's what I'm looking for. That's going to be equal to, according to my formula up here, the limit as h approaches 0 of f of 1, a is 1, plus h minus f of 1 all over h. Okay, and I'm doing this using this formula where a, they're going to give me that point as 1. So now I'm going to slide this up so everybody can see it. What is f of 1? That's going to be 1 squared plus 5 times 1 minus 2. 1 squared is 1, 5 times 1 is 5 minus 2, 5 minus 2 is 3, plus 1 is 4. F of 1 equals 4. Does that make sense so far? Another question for you. What is f of 1 plus h? This is that functional notation stuff. I don't care what's inside the parentheses. Whatever's inside the parentheses is what you replace x with in f of x function. Okay? So this is going to be equal to 1 plus h squared plus 5 times 1 plus h minus 2. All I did was take my function, x squared plus 5x minus 2, and replace all the x's with 1 plus h. So far, so good? So here we go. So this f prime of 1 is equal to the limit as h approaches 0 of f of 1 plus h, which would be 1 plus h squared plus 5 times 1 plus h minus 2. I'm putting parentheses around that because that's replacing the f of 1 plus h. All I did was copy them down, put them there. Minus f of 1. F of 1 was 4. So I literally plug it in all over h. Now I'm going to clean this guy up. So here we go. F prime of 1 will be equal to the limit as h approaches 0 of 1 plus h squared. Now what does 1 plus h squared mean to you guys? What does square mean? Times itself. So 1 plus h squared is 1 plus h times 1 plus h. Here I'm going to distribute 5. That'll be plus 5 plus 5h minus 2 and then minus 4 all over h. Now I got to clean it up some more, but to clean up 1 plus h times 1 plus h, I'm going to have to do the famous FOIL method. 1 plus h is not just 1 squared plus h squared. It doesn't work like that. 1 plus h times 1 plus h, you got to pull it out. So here we go. This will be equal to the limit as h approaches 0 of 1 times 1 is 1. 1 times h is h times 1 is h, and h times h is h squared, plus 5 plus 5h minus 2 minus 4 all over h. So this f prime of 1 is equal to, now I'm going to clean this guy up. Zoom in on this guy, you guys can see it back there. All right, here we go. What is h plus h? That's 2h. All right, and wait a minute, plus another 5h. What's 2h plus 5h? I'll clean that up, make that 7h. Okay, those guys are gone. Plus h squared. Well, watch this. What's 1 plus 5 minus 2, 4 minus 4? 0. All the constants cancel. You get 0 all over h. Does that make sense? This thing cleans up nicely when you do this. So 1 plus 5 is 6, minus 2 is 4, minus 4 is 0. All my constants cancel. H plus 5h is where the 7h came from, plus an h squared. Now remember, oh, and I forgot the old limit as h approaches 0 there. The ultimate goal of taking a limit is, when h goes to 0, is to cancel something off the bottom. This is a 0 over 0 case, because right now if I plug in 0, 0 for h, I get 0 divided by 0. Something's got to cancel. You only cancel through strict multiplication division. So what I'm going to do here is I'm going to factor out an h, and that gives you with a 7 plus h over h, and the h is canceled. This is equal to the limit as h approaches 0 of 7 plus h. Now I'm going to evaluate the limit, and when I evaluate the limit is when I don't write limit anymore, right? So now I'm just going to plug in h is going to 0. That'll be 7 plus 0, which is 7. Which there tells me, 3 dots in a triangular fashion means therefore, this derivative evaluated at 1 is equal to 7. What this tells me is, if if I look at the function f of x, which is equal to x squared plus 5x minus 2, if you focus on at the point x equals 1, the slope of that tangent line that only hits that graph at that one spot at 1 is actually equal to 7. 7 over 1. I'm expecting a numerical value when I'm asking for the slope of the tangent line. It's a number 7. But here's my problem. I give you a problem like this, and this is how you use the formula to figure out the slope of the tangent line at a particular point. This is famous limit is h approaches 0 of f of a plus h minus f of a all over h. But I give you something like this. Here's the function, f of x equals x squared plus 5x minus 2, and I want you to find the slope of the tangent line of f of x at x equals 1. Ah, I'm sorry. I meant x equals 2. My mistake. What do you have to do? I got to do this whole freaking problem over again, right? Everything. I got to sit there and go, it would be f prime of 2 would be the limit as h approaches 0 of 2 plus h minus f of 2 over h. I got to calculate what f of 2 is. I got to do f of 2 plus h. I got to plug in. I got to do this whole problem all over again. That is why we've given you this formula here. So this will be part B of my problem. Let me get a nice little another clean sheet of paper here. Part B of this problem, and I'll write it up here so you guys can see the comparison. Part B is going to ask you find the derivative of f of x, which is still x squared plus 5x minus 2 using the definition of derivative. Okay, and so I'm going to kind of slide this paper up so you guys can see this. All right, so here's my new problem. Part B is the same problem except for I changed my wording. I want you now to find the derivative. The derivative, we're talking about the derivative function. Okay? What is the derivative function? We have a formula. F prime of x. This is called the derivative function. F prime of x. Not of a constant, of x. This is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Listen to my words because this is important. When you hear me say, use the definition of derivative, this is what I expect to see. You should be copying this problem down because it's an excellent problem of the type that I would be putting on a test. Use the definition of derivative. It is this, and you got to memorize it because it's calculus. We make you memorize everything. F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Now I gave you f of x squared plus 5x minus 2. So f of x plus h would be what? I don't care what's inside the parentheses. Whatever's inside the parentheses is what I replace x with in the f of x function. So this would be x plus h squared plus 5 times x plus h minus 2. All I did was replace all the x's with x plus h. Now this is a large process, but don't worry, I'm going to help you guys out today. So here we go. This formula would be equal to the limit as h approaches 0 of f of x plus h, which is this x plus h squared plus 5 times x plus h minus 2 minus f of x, just recopy of f of x down, which is the x squared plus 5x minus 2 all over h. It's the f of x plus h minus f of x all over h. You guys know this better as the old difference quotient. You guys have been beating death this difference quotient since junior high school. Once you discover the function of f of x notation stuff, we've been grooming you for this f of x plus h minus f of x all over h. I guarantee you, your high school teachers beat this thing to death. Now here we're going to beat it one more time and get a solution. But this will be a functional solution when I'm done. So let's take a look at this guy. I'm going to clean this guy up. So f prime of x would be equal to the limit as h approaches 0 of, now x plus h squared means x plus h times x plus h. Here I'm going to distribute the 5 into the x plus h. So it gives me plus 5x plus 5h minus 2. Now this negative is going to distribute into the f of x. That's going to give you minus x squared minus 5x plus 2. When you distribute a negative, it changes the signs. All over h. Let's clean this up one more time. To clean it up, x plus h squared means x plus h times x plus h. And once again, I'm going to do the FOIL thing on this guy. This would be equal to the limit as h approaches 0 of, FOILing this out, x plus h times x plus h is going to be x squared plus xh plus another xh plus h squared, classic FOIL, plus 5x plus 5h minus 2 minus x squared minus 5x plus 2 all over h. So this f prime of x will be equal to the limit as h approaches 0 of, let's clean this guy up. What do you notice about this function? Well, first thing you should really notice is once you clean this thing up, half this stuff's going to cancel. Watch. X squared minus x squared cancels. Plus 5x minus 5x cancels. Minus 2 plus 2 cancels. The entire function cancels. Now let's group together like terms. What is xh plus xh? What do you got? 2 xh's, combining that, plus h squared, okay, plus 5h. These two terms combined, this term and this term. That's all I got left over an h. And what do you notice you have in common in every term in the numerator once you clean it up? An h. So to do a limit, and you remember the ultimate goal on any limit is to cancel out this denominator because this is another 0 over 0 case here. You want to cancel that h and you need to factor it out. So this would be equal to the limit as h approaches 0 of, factoring out that h, leaves you with a 2x plus an h out of the x squared plus a 5. I'm pulling the h out over h. H is canceled. So f prime of x is equal to the limit as h approaches 0 of 2x plus h plus 5. So all this work is to cancel that h off the bottom. Now, what's the last thing I do? You're taking the limit as h approaches 0. Make h, only h, not x is here. H is going to 0. Make h go to 0. And once I plug in h, I don't write the limit anymore. This will be 2x plus 0 plus 5. Therefore, your derivative, cleaning it up, is equal to 2x plus 5. When you take the derivative, definition of derivative, you're expecting a functional answer, 2x plus 5. Now, why is this so important? Because of this. What is the slope of the tangent line at x equals 1? The derivative helps you calculate what the slope of the tangent line is. We're just plugging in x is 1. This is going to be, by definition, f prime of 1. This is what we did last time on this particular problem. We calculated f prime of 1. What do we end up getting over here? 7. Let's try it now. This is now using the functional notation. I'm just going to replace x with 1 in my derivative function. This will be 2 times 1 plus 5. What's 2 times 1 plus 5? Yeah, pretty much 7. Now, but remember that problem I told you about? Oh, I'm sorry, I made a mistake. I didn't mean 1, I meant 2. No problems. You want the slope of the tangent line at x equals 2 is going to be equal to f prime of 2, which will be 2 times 2 plus 5. 2 times 2 is 4. 4 plus 5 is 9. Slope of the tangent line is 9. Oh, man, I'm sorry. I didn't mean 2. I meant negative 2. No problem. The slope of the tangent line at x equals negative 2 would be f prime of negative 2. That'll be 2 times negative 2 plus 5. 2 times negative 2 is negative 4, plus 5 is 1. Oh, I meant the slope of the tangent line at x equals negative 4. No problems. F prime of negative 4 would be 2 times negative 4 plus 5. I'm plugging whatever slope of the tangent line at what point you want. I just plug it in my derivative and it will calculate my slope of the tangent line. 2 times negative 4 is negative 8 plus 5 is negative 3. So over here I'm sloping down. Sloping 1, slope is 9, slope is 7, so forth and so on. The derivative function is a formula for this quote-unquote slope of the tangent line. And so my point is, if I did find the slope of the tangent line at x equals 2, if I did it this way, using this definition up here, I would have to redo the entire problem every time I change my mind on what x is. But once I get the derivative function here, all I got to do now is plug the number into x, and it saves me buku of time. The derivative function is much more important than the derivative formula, okay? Because the formula only gives you the slope of the tangent line at one point, and then you change the point, well, you got to do the whole problem all over again. This one, I can change my mind which way I want to. Does that make sense? But here's my problem. And again, I want to iterate this because I'm drumming it into your head. When am I going to do this kind of a problem? When you hear from me, and on the notes, and when my test, when I tell you the words, use the definition of derivative, this is what you do. This is the work you see. And it is intense, but once you got the derivative formula, you can beat it to death. The definition of derivatives. The problem is, this takes a while. I didn't take just 30 seconds to do this problem. I actually had to do it in quite a bit. There is an easier way to take derivatives, and that's what we're going to teach you today. But how do I know to do the easier way, and how do I know to do it the long way? When I tell you these words, when I tell you the words, use the definition of derivative, I want to see this. If I ask you to take the derivative of something or other, I'm going to show you the short way, because this takes too much time, and the key to math is notice a pattern. We noticed patterns when it came to this stuff about 400 years ago. So we now, by looking at functions, we can actually take the derivative a lot quicker. But this is the definition. This actually shows the work in getting derivative. We're going to show you guys today on how to take derivative of much easier stuff. And the trick is this, okay? I'll just write them down here. Because there's two formulas that we're going to focus on the derivative of. Derivative formulas. The first one is this. If f of x is equal to c. C is a constant. I don't care what the constant is, it's a constant. The easiest letter is c. Do you know what the derivative is? Well, we talked about a little bit about this last time. The derivative of a constant. We know what a constant looks like when you graph it. Y equals a constant, y equals 5. It's a horizontal line. And remember, the derivative is this slope of the tangent line deal here. What is the derivative of a slope of a horizontal line? What's the slope of a horizontal line? What's the derivative of that? 0. So it's real simple. If I give you a function that's a constant, the derivative is going to be 0. What's the derivative of 5? 0. What's the derivative of -7? 0. What's the derivative of pi? 0. Pi is 3.141593969, whatever. It's a constant. The derivative of that's going to be 0. These are the formulas. It's so much easier to take derivative. Second formula. If you've got a function that is equal to a constant times x, what's the derivative? Well, when you put a formula in a line form, y equals mx plus b. Remember that slope-intercept form? Y equals mx plus b. What's the slope? The m. It's the coefficient in front of the x, right? So what is derivative of a constant times x? It's just a constant. It's the slope part. It still be constant. So here's another easy one. What's the derivative of 5x? 5. What's the derivative of 17x? 17. What's the derivative of pi x? Pi. What's the derivative of -4x? -4. It's the coefficient in front of the x. That's the derivative. These are the patterns. And there's one more. You know you're in trouble when they got names. This guy's called the power rule. If I give you a function which is x to the n, okay? X to the n. The derivative, where n is going to be any power you want it to be. Fraction power, your negative exponent, don't matter. The derivative is going to be, here's the pattern that we call. What happens when you do this limit definition of derivative stuff? The power gets to basically go out front as a constant, n, x, and then you subtract one from the power. The derivative is going to be n x to the n minus 1. So, what is the derivative of? Get another piece of paper here. What is the derivative of x cubed? You take the power, and you bring it out front. 3x, and then you subtract one from the power. 2. What is the derivative of x to the 8th? 8x to the, what is the derivative of 1 over x cubed? First things first, clean him up. 1 over x cubed, we don't like stuff on the bottom. You can bring stuff off the bottom to the top using negative exponents. This is x to the negative 3. What's the derivative? Bring it down front, negative 3x, and subtract 1. But be careful. What's minus 3 minus 1? Negative 4. And you can clean them up if you want to, make them negative 3 over x to the 4th, but we'll take it either way. But you got to clean them up first. Does that make sense? What about f of x is equal to the square root of x? I don't do square roots. What's a square root? Very good. Radicals are fractional powers, right? So this is going to be x to the 1/2 power. So the derivative is going to be, bring down the power, 1/2 x subtract 1. A half minus 1 is a negative 1/2. And that's fine if you want to clean them up. Negative exponents go on the bottom. Half a power is a square root. This would be 1 over 2 is already on the bottom. 2 square root of x. It's the same thing. But now you're beginning to see the fastness, the quickness of taking the derivative. A couple more rules, and then we're going to go to our little notes here. And that is this. If y equals a constant times a function, then the derivative, a little prime notation derivative, is equal to a constant times the derivative of the function. Okay? In English, constants hold over. Okay? So, an example of that would be this. If f of x is equal to 4x cubed, what's the derivative? Now, we're going to eventually get you to do this stuff in your head, but constants being multiplied, hold over. Leave the constant on. Leave that 4 on. You go after the x, or wherever the variable is, whether it be a t or a z or whatever. What's the derivative of x cubed? Bring down the power, 3, x, and subtract 1, 2. And then just clean up your constants. What's 4 times 3? 12, x squared, subtract 1 squared. 12x squared. That's the derivative. Derivative of 4x cubed is 12x squared. Hold the constant and then just multiply your power out front. Does that make sense? Okay. One more. F of x is equal to 5 over x squared. That would be the same thing as 5x to the negative 2. Then the derivative is going to be what? Hold the 5. Then the derivative of negative x to negative 2 would be negative 2x subtract 1, negative 3. That would be negative 10x to negative 3 or negative 10 over x cubed, which way you want to write it. Constants hold over. And then the last formula for this section I'm going to give you is this guy here. If y equals a function plus or minus another function, then when you take its derivative, you just take derivative of the first guy, plus or minus, you take derivative of the second guy. That only works with adding or subtracting. Multiplying and dividing, we got different rules for that. Those are big rules. Those are coming down the road. So, here we go. If y equals x squared plus 5x minus 2, what's the derivative? Y with a little prime on it. What's the derivative of this guy using my rules? Well, when you take derivative of things being added or subtracted, you take derivative of each one. What's the derivative of x squared? You bring down 2x, subtract 1 to the first power. We don't write the first power. 2x to the first. Plus, here's a rule. What's the derivative of 5x? Constant times x. What's the derivative? Constant 5. Minus, what's the derivative of 2 being a constant on? 0. Derivative of constant is 0. Derivative of constant times x is just a constant, and then you got the power of x at the end. So when you clean this up, this is y prime equals 2x plus 5. Right? And if you notice back up here when we did this problem, this was all the work we did for it. Using the definition of derivative, the function was x squared plus 5x minus 2. We did all this derivative stuff. What did we end up getting for the answer? 2x plus 5. Well, I just did it the short way. What's the derivative of x squared plus 5x minus 2? 2x plus 5. So let me reiterate. Does that mean we don't have to know this stuff? No, it doesn't mean that at all. It means when are we gonna make you guys do the long way? And I won't ask you many problems on the test like this, but I'll ask you one or two, and you'll know to do this. Use the definition of derivative. This uses the definition of derivative. So let me make it clear. If I tell you in a problem on a test, use the definition of derivative, and you don't show me all this work, and you just say, oh, analyze it, and it's clearly 2x plus 5, it's a 10-point problem. How many points am I going to take off? About 15 or 20, because you didn't follow directions. So be careful on this. Pay attention to directions. So yes, you could actually make a negative grade on my test. It says use the definition of derivative. I want to see this. If I tell you to just take the derivative, knock yourself out. That means I want short method. And that's most of the problems I'm going to give you, but these will be the big point totals because this is using your algebra skills. Does that make sense? All right. So let's come over here and let's do some problems off of our notes. All right, so this whole section, 2.3a, definition derivative and what I call that power rule. So kind of gone over it with you, but let's fill out our stuff here. It says this. For any given function, y equals f of x, the derivative of x, of f, at x, is defined to be, this is the definition. What is f prime of x equal to? What's my definition of derivative? It is the limit as h approaches 0 of f of x plus h minus f of x all over h. We do expect you guys to know this formula, provided the limit exists. This is your limit formula. Okay? Now, this is terminology. Just trying to get you guys into the terminology of this stuff. If f prime of x exists, then f is said to be, and the word is differentiable. So, when you hear the words differentiable, it means you can take the derivative of a function. Differentiable. It's just terminology, so getting used to the calculus terminology. Differentiable. Okay? Finding the formula for f prime of x, given f of x, is called differentiating. Differentiating. So that means when you're differentiating, you're taking the derivative. Again, terminology here. And the process itself is called differentiation. Differentiation. So we're drumming the words into your head. Okay? The three-step method for finding the derivative. All right, again, terminology here. Now, I'll beat this one to death on you guys, and so did your high school math teacher. So let's know in this first one. Three-step method for finding derivative. Form the ratio of f of x plus h minus f of x all over h. We called the, you remember what those guys were called? You got difference quotient. Okay. Part B, what do we suppose to do this different? We beat it up. We do f of x plus h, clean it up, pull it out and stuff. We subtract f of x, half the stuff cancels. That's called simplifying. Okay. You simplify the difference quotient algebraically. And then you calculate the derivative, f prime of x, by taking the limit after you clean it up as h approaches 0 of the f of x plus h minus f of x all over h difference quotient, if it exists. Okay? Now, in terms of this non-existent thing here, take a look at number 5 here. A function f of x is not differentiable at x equals a for any of the following is true. Okay? So when is it not differentiable? You can't take the derivative at that particular point. Okay? Number 1, f of x is discontinuous at x equals a. What does it mean to be discontinuous? You've got a break in the graph. So give you a little visual aid here. So if I got this function does this and does this type thing here, if you got a break in your function, right at that point A, whatever that A happens to be, the function is not differentiable. You can't be differentiable over a broken spot. You got to be continuous. Okay? The other one, another place that the function is not differentiable. The graph of f of x has a, what they call a sharp turn at x equals a. The fancy word for that is the word cusp. Okay? A cusp is a sharp turn. You know, the old absolute value graph, the old V graph and stuff, that point right there, right at A, that point is not differentiable. The sharp turn. And let me explain why. With this sharp turn, on the left side, remember the derivative is the slope of the tangent line. It's a function for the slope of the tangent line, but the slope of the tangent line on this side is actually pretty constant. It's a negative number, like -1 or something like that. The slope of the tangent on this side is going to be an actual positive number, +1. So right before you go from a negative slope to a positive slope side, that point we say the derivative does not exist because you can't transition from a negative right to a positive. You got to go through a transition phase. So because of that, it's not differentiable. No sharp turns, cusps. No cusps. Okay? They're not derivative, not differentiable there. The last one is if the slope of the tangent line at x equals a is a blank. Okay, blank actually. Okay? All right. The other deal is this. We are again beating up the depth. Slope of the tangent line. Tangent line. When does a slope not exist? What kind of line does a slope doesn't exist at? That one. The vertical line. One looks like this. Horizontal lines have zero slope. Vertical lines have no slope. Does not exist, right? And since the derivative is the slope of the tangent line, if you've got a tangent line that's a vertical slope, it doesn't exist there. So the tangent line at x equals a is a vertical line. That vertical line. So if I give a function looks like this, let me see if I can draw one in here. Comes in here and does something like this. See that point right there? It's got that vertical tangent line. So I'm trying to exaggerate it there a little bit. That point right there at x equals a, and that a, that derivative does not exist. If you've got a vertical tangent line, if it goes vertical on you, in terms of the sloping, the derivative won't exist there. Does that make sense? Because derivative is a formula for the slope of the tangent line. Okay? Now, the function f of x is continuous. How do I define continuity? Being continuous at x equals a. Well, here's the deal. To be continuous. Now, in high school, college algebra, we teach our students, you can't lift your pencil from the paper. And don't get me wrong, that's an absolutely brilliant definition of being continuous. When I graph it, I don't lift my pencil from the paper. See, this was discontinuous here. I had to stop, pick it up, and go over again. That's a great working definition, but it's not a mathematical definition. A mathematical definition is this. A function is continuous if three things occur. When you take the limit as x approaches a from the left of f of x, and that's equal to the limit as x approaches a from the right of f of x. Right there, that means that the full limit as x approaches a of f of x, exists. Because the limit from the left is equal to the limit from the right. But to be continuous, it also has to be equal to the functional value at that point, f of a. So these are three things that have to hold. The limit as x approaches a from the left of f of x has got to be equal to the limit as x approaches a from the right of f of x, which has got to be equal to f of a, where the dot is located at. If all those things are the same point, you'll be continuous at that point. Basic rules. All right, so as we continue on with this stuff. All right, so this is what I was talking about before, but this is their fancy way of writing it up. I thought I'd give you my own little take on this stuff, so hopefully you took notes on that. The basic rule of the derivative of a linear function, y equals mx plus b, that states that y prime equals what? We're beating to death. The derivative is the slope of the tangent line. We put it in slope-intercept form, y equals mx plus b. What's the slope? What letter is the slope? M. So y prime equals m. The derivative of a constant times x plus b is just going to be that constant. Reason for that? Derivative of constant times x is a constant plus what's the derivative of constant by itself? 0. So that part goes away because it's going to be equal. And here we go. If f of x equals a constant, then f prime of x equals what's the derivative of 5? 0. What's the derivative of -7? What's the derivative of a constant? 0. Derivative of a constant, 0. Here's the next one. What's the derivative of x? Trying to throw a curveball at you guys. Remember, derivative of a constant times x is just the constant. What's derivative of x? What's the constant from this thing? You don't write him down there, but you understood he's always there. 1. Derivative of x by himself is 1. It's 1 times x is 1. Okay? And then the next one is, this is called your power rule, so you know you're in trouble here. You start labeling these guys with names. Power rule. If f of x is equal to a constant times x to an r, they're just switching up the letters here, where c and r are any real numbers, then f prime of x is going to be, remember, constant holds over. What's derivative of x to the r? How do you take a derivative? We're doing the short method called the power rule. You bring down your power times r, x, and then what do you do with your power? Subtract 1, r minus 1. That's the fancy rule for this. Now, again, going and watching our awesome Hawks TV on that little video example they do, you got to go to www.hawkstv.com and watch their little example here. Here are some similar examples they do. Here it is. F of x equals 8x cubed. What's the derivative of this thing? This is our power rule. Labeling is everything in calculus. This sucker's called f of x. Its derivative is called f prime of x. And that prime is very, very important. Now, 8's a constant. Leave it alone. What's the derivative of x cubed? You bring down your power, 3x, and subtract 1, 2. And then you clean them up. What's my derivative? What's 8 times 3? 24x squared. That's using the power rule. They didn't say use the definition of derivative. They said use, basically take derivative. I even told you, use the power rule. Look at the next guy. F of x equals 2 times the cube root of x. Number one, I don't do radicals. Clean him up first. And then I will repeat this until the end of the semester. Clean him up first. You're in calculus class. 60% of calculus is algebra. Clean it up first. I don't do square roots. Square roots are half a power. I don't do cube roots. What's a cube root? Third of a power. So this is going to be equal to 2x to the 1/3 power using my fractional exponents for radicals. Now, take the derivative. F prime of x. 2 is a constant being multiplied. It holds over. What's the derivative of x to the 1/3? You bring down your power, 1/3 x, and you subtract 1. 1/3 minus 1 is how much? Negative 2/3. Just to show you. 1/3 minus 1 is 1/3 minus 3/3. 1 minus 3 is negative 2/3. Just want to show you the fraction thing here. We expect you to do this in your head. 1/3 minus 1 is negative 2/3. So cleaning this up, you get f prime of x is equal to 2 times 1/3 is 2/3, x to the negative 2/3. And when you type this in on your Hawks homework quiz, whether it be lessons or whatever, they'll accept it like this. But if you really wanted to clean them up, you know, you can clean up that negative exponent. You can also write this as 2/3x to the 2/3. Negative exponents go back where they came from, which is on the bottom. But honestly, I'm going to leave my answers pretty much like this. We're in calculus class. We're not in algebra class. Does that make sense? All right. So, based upon this, let's start doing some practice problems. And I'm going to beat it into your head. Here it is. Clean it up first. So, y equals 8 divided by x to the 4th. Taking derivative, and it says using the power rule, but basically it says take derivative. The only time I'm going to do this limit as h approaches 0 of f of x plus h minus f of x all over h. It will be in my wording. Use the definition of derivative to let you know it go that way. Okay, so on this one, we'll clean them up. I don't like stuff on the bottom, so this will be 8x to the negative 4th. So the derivative y prime is going to be, well, derivative of 8x to the negative 4. You bring down your power. Now I expect you guys to multiply in your head. What is negative 4 times 8? Negative 32x, and then subtract 1. Minus 4 minus 1 is a minus 5. And you can clean that to be negative 32 over x to the 5th. Now, I skipped some steps because I did it mentally. I took my power and multiplied it. So negative 4 times 8 is where the negative 32 came from, x, and then I subtract 1 to the negative 50. And, of course, we will accept this answer on the computer. Does that make sense? And on your test and everything else. But if you want to clean them up, You look in the back of the book for the solutions, they write it like this, don't be surprised. Y equals -3 divided by the 5th root of x. First things first, clean them up. -3x. Now, a 5th root is what? Square root's a 1/2 power, cube root's a 1/3 power, a 5th root is a 1/5 power, but he's on the bottom, so when I clean him up to the top, I'm going to make him negative. So, no calculus at all. This is all algebra. So, y equals -3 over the 5th root of x, same thing as x equals -3x to the -1/5 power. You with me? So now, take derivative. And what is, bring down your power. What's -3 times a -1/5? What's a negative times a negative? Positive. What's 3 times a 5th? 3/5 x, and subtract 1. Subtracting 1 from a -1/5. And I'll do that over here. -1/5 minus 1, that's -1/5 minus 5/5. -1 minus 5 is -6 over 5. That'll be x to the -6/5. And we're going to start leaving the answer with the negative exponents. It's good enough. Does that make sense? So I am doing a lot of mental math here with the multiplying and the adding stuff here and subtracting. So whether it be fractions or decimals, don't care. And so this one, y equals -4x to the 9.6. All right, so my derivative is going to be, labeling is everything, y prime. -4 is a constant, leave them alone. I'm going to bring down my power, 9.6x. And then I'm going to subtract 1. What is 9.6 minus 1? 8.6. And then the last thing I'm going to do, I'm going to grab the handy dandy calculator on this one, is multiply -4 times 9.6. -4 times 9.6 gives me -38.4 x to the 8.6. That is my derivative. Does that make sense? The next one. Y equals -5x to the 6/7. So y prime, -5 is a constant, leave them alone. X to x to the 6/7. Bring down the 6/7 x and subtract 1. What is 6/7 minus 1? -1/7. Very good. And so clean this up. But you multiply fraction, multiply numerator, multiply denominator. -5 times 6 is actually -30 over 7 x to the -1/7. Does that make sense? All right. And the goal, if you'll notice, we're taking these derivatives, these formulas for the slope of the tangent line very quickly, and we're going to speed up our processes here so we can do applications of this stuff. So, what is the derivative of 4x plus 6? We call that sum difference rule. You take the derivative of each term. So, what is the derivative? And this will be my little arrows here. What's the derivative of 4x? 4 plus, what's the derivative of 6, being a constant by himself? 0. So, what is my answer? Y prime equals 4. Sum or difference, take the derivative of each one and just add or subtract them. Okay? So, and the last but not least, y equals -6x cubed. What's the derivative of this thing? Do it in your head. Tell me what the answer is. -18x to the 2nd power. The 3 times the -6 is where the -18 came from. X, subtract 1. 3 minus 1 is 2. -18x squared. Does that make sense? And again, what the purpose of this stuff is to take the derivative very quickly. So one more before I let you guys go. Then you can go certified. All right. Here we go. If g of x is equal to 5x cubed plus 7 over x minus 6 over the square root of x plus 5x plus 27.2. I want you to take the derivative of this thing. What's the first thing I'm going to do? All right, you guys are going to quote me after a while. First thing you do before you take a derivative, clean it up. Get it to a form All we got is formulas for constants by themselves, a constant times x, and something x to a power, raised to a power. So I don't like stuff on the bottom, I don't like radicals, so forth and so on. So first thing, I'm gonna just clean this guy up. So g of x, so labeling is everything. This is still the same function, I'm just cleaning him up. 5x cubed plus, I don't like stuff on the bottom. X on the bottom brings to the top, it'll be 7x to the -1 minus 6. I don't do square roots. Square roots a half a power. On the bottom would bring up, that'd be 6x to the -1/2 power plus 5x plus 27.2. So now the derivative. G prime of x. Now we apply our rules. I'm going to do the sum difference rule. That's what it's called. Take derivative of each term, adding or subtracting. I'm going to take derivative of each one. So on your mark, get set, go. What's rid of 15x cubed? I screwed that up. Try again. What's rid of 5x cubed? Sorry, I already going in my head. What's rid of 5x cubed? 15x squared. What's rid of 7x to -1? -7x to the, subtract 1, -2. Minus, watch this one, what's derivative of -6x to the -1/2? Right, -1/2 times the -6 is plus 3, x to the what? Subtract 1. -3/2 plus, what's derivative of 5x is 5, and the derivative of 27, this is for your benefit, 0. Typically I don't like 0, but there it is, 0. And then, one last thing. If you're going to get that back through the book, look to this thing, clean them up one more time. This will be 15x squared minus 7 over x squared plus 3 over x to the 3/2 plus 5. There's the cleaned up version of your answer. But honestly, we on the computers and the test and stuff will be more than happy to take those darn negative exponents and bother to us. You can just write, don't plus 0, waste your time there. But the rest of it's good to go. Practice this stuff. It's real important, okay? You got to get really good at this stuff, okay? Good luck. See you guys, and we'll finish up section 2.3 next time.